always do on Tuesday, right?
So nomenclature is a fancy word that just means a system of naming compounds. So there are different systems for naming different types of compounds, just like different countries and cultures have different systems for naming their children, right? So we need to be able to identify what type of compound so that we can use the correct system. Because someone from India is not going to use the same system for naming their children as someone from Korea or someone from Canada or someone from Sweden back in the old days when you took your father's name and then you slapped son or daughter onto the end. I would have been Jody Dean's daughter. You know, the last name changed every generation. That makes genealogies a little confusing. We have to identify the type of compound. Many compounds also have common names, they're sort of nicknames, but we're going to learn to write their official name. There are two compounds that always go by their common names, and you need to know these. One of them, you probably already know, is water. Water is H2O. This is its common name, but it is so common that we all call it water. You can call it dihydrogen monoxide, and if you want to scare your mom or your friends, I drank dihydrogen monoxide in lab today, I'm going to die. No, you're not. You drank some water. Big deal. But it's fun to say and scare people. The other one is ammonia. Ammonia has the formula NH3. Its name is ammonia. And so you need to know that. So there's two more for your flashcards. So we're going to talk about naming ionic compounds. The first thing you have to do is identify it as one. And we've already practiced this. If you have a metal and one or more nonmetals, it's an ionic compound. So you look at the formula, you ask yourself, is the first element a metal? If the answer is yes, it's ionic. If it's NH4, it's also ionic. This is that one little annoying exception. But if it's a metal, it's always ionic in this class. Your book goes into this classification of two different types of metals. I think it's a little bogus, but it's there, so we'll do it anyway. Ionic compounds, metal and nonmetal. You can have metals that form only one kind of ion. Those are the ones we've talked about so far, the ones in groups 1A, 2A, 3A, zinc, and silver. And then the rest of them form more than one type of ion. So for metals that form only one type of ion, here we're talking about the elements in group 1A, group 2A, group 3A, and then zinc and silver. The name of the ion is exactly the same as the name of the element. So lithium ion is a lithium atom that's lost an electron. It doesn't have a special name. And this is a little bit like when a man and a woman get married, the man generally doesn't change his name, right? But the woman traditionally would change her last name, the ending of her name, and we'll see that these non-metal ions do that. But these guys, it's just their name. You see that triangle that just flashed in there? Oops, I thought it was going to do a little more. It did not. So there's kind of this magical little triangle there. So here's aluminum. It's +3 because it's in group 3. We also need to remember zinc and silver. So zinc is actually right here. I'll change to a black pen. So here's zinc. Zinc is 2+. And here's silver. Silver is 1+. So aluminum, zinc, silver. They're kind of like a stair step here. Aluminum's 3, zinc is 2, silver's 1. So you need to remember the charges on these, but it's really not that bad. So I'll be repeating this a lot. Group 1A, 2A, 3A, zinc, and silver. Those metals, when they form ions, the name of the ion is the same as the name of the metal, and we can predict their charges based on where they are in the periodic table. Groups 1A, 2A, 3A, zinc, and silver. I should make up a song. So here's a table of those. Calcium's in group 2A, positive 2 charge. Aluminum is in group 3A, positive 3 charge. Zinc's +2 because it is. Silver's +1 because it is. All the other metals can form more than one ion. So iron can form a 2+ ion and a 3+ ion. And there's not a good way on the periodic table to even tell us which ones are possible. And you don't know which ones are possible, that's fine. But when I give you one, you name it. When I give you the name, you write the formula. So what we do in the name, instead of just calling it iron, because then we wouldn't know what the charge is, we put the charge in Roman numerals. So Fe2+ is iron 2. Fe3+ is iron 3. These are capital I's. Those are not lowercase l's. If you type these names into Mastering Chemistry and you use lowercase l's, it will look exactly the same as if you do capital I's, but it'll tell you it's wrong. And you'll tear your hair out, and you'll send me all these sob messages by text, and yeah, that's happened before. Brief review of Roman numerals. So 1 is capital I. 2 is 2 capital I's. 3 is 3 capital I's. So far, so good. But if you just kept doing that, it's like, how would you write 100? And who wants to count them? That wouldn't work out. Let's skip to 5. 5 is capital V. If you want to know why, go ask the ancient Romans. They made this up. 4 is the number before 5. Right? It's 1 before 5. So it's a capital I before 5. It's 1 before 5. And 6 is 1 after 5. And that's probably far enough for Chem 3A. Okay? Yeah, I don't know how they did math. It's maybe why they don't exist anymore. It's because of their numbering system. Iron 3, the Roman numeral 3 tells us it's a positive 3 charge. We know it's positive because it's a metal, and metals always form positive ions. So here are some of the more common ones. So here's the element chromium. It forms a +2 ion and a +3 ion. We don't need to know that it does that, but if we see Cr2+, we know that's chromium 2 ion. Cr3+ is chromium 3 ion. This is an older system of naming that you might run across, where they used us and ic as the endings. There was chromous and chromic ions. I just want you to have seen it. It exists. I won't ever ask you a question like that on an exam. We're not supposed to be using it anymore. UPAC said we're not doing that anymore, but people still do it. It's out there. Okay, so we've talked about cations. Monoatomic anions. We learned how to predict these charges. This is just a nonmetal by itself, and we predict the charge from the periodic table. We need names now. The nonmetals in Mrs. K's chemistry land are female. And so when they hook up with a metal, that's like getting married, right? They form a compound, they form a union, and so the nonmetals change the ending of their name. So fluorine is the name of the element, fluoride is the name of the ion. So the base of the name, the first part stays the same, fluor, but then it changes to ide instead of ene. So we get chloride, bromide, iodide, oxide, sulfide, nitride. The charges are based on their position in the periodic table. In this class, we will only see ionic compounds that have 2 ions, cation and anion. There are ionic compounds that exist that have multiple cations, multiple anions. We can safely ignore them. So when we name the compound, we name the cation first, and then we name the anion. The cation is usually just the first element. It's a metal. The exception is if it's NH4. And then the anion is everything else. It might be a monatomic anion, or it might be a polyatomic anion. So let's practice this. So here, KBr. What kind of an element is K? Potassium. Is it a metal? Yep, it's a metal. Does it need a Roman numeral in its name? How do we know? Well, if it's in group 1A, 2A, 3A, zinc or silver, we don't need a Roman numeral. This is in group 1A, so we don't. So then we just write the name of that element is potassium, because it's the guy, doesn't change his name. And then Br is the anion, bromide. So it was bromine, and when she gets hooked up with potassium, she changes the ending of her name to bromide. Potassium bromide. What about this one? Zn. Does that form more than one kind of ion? Is it in groups 1A, 2A, 3A, zinc or silver? Duh. Yeah, it's zinc in the groups 1A, 2A, 3A, zinc or silver. Just the element name. So this is zinc. And here we have nitrogen, nitride. Zinc nitride. We do not need to do anything with the 3 and the 2. The charges are the reason that it has those numbers. We do not need to specify that in the name. We just name the cation, we name the anion. If the metal isn't in groups 1A, 2A, 3A, zinc or silver, then we're going to have to specify the charge when we give the name of the metal. And so we're going to have to figure out what the charge is, and we do that by looking at the charge on the anion and looking at how many cations and anions are there. So we need the charge on the anion first, and then we figure out the charge because the charges have to add up to 0. So let's do an example. Let's look at Fe2O3. This is iron. Iron is not in groups 1A, 2A, 3A, zinc or silver. And so this is going to need a Roman numeral. So we can start writing the name. That's, oops, got to choose a pen. It's iron, and because it's not in groups 1A, 2A, 3A, zinc or silver, it needs a Roman numeral. This also goes along with the whole guy-girl thing, because I can't think of any woman who is like Jane Smith IV, right? But John Smith IV, you know, that could happen, certainly. So the Roman numerals are only for metals, and not for all of them, just these ones that need it. And then oxygen would change her name to what? Oxide. So we've got iron blank oxide. I put the parentheses in there right away because I need to leave a space for them, and now we're going to go figure out what the charge is. So I've got 2 iron ions. I don't know what the charge is. And I've got 3 oxygen ions, and I know that these are 2 minus. So I'm just kind of drawing a picture for myself. So if I have 3 oxygens, the total negative charge is 6, right? -2 from each of them. This is a neutral compound, so the total positive charge has to be +6, right? So I'm going to take this +6 and I'm going to divide it equally between 2 ions. It's not too hard. They're each what? +3. So this is 3+, and this is 3+. So this is iron 3. So I put 3 capital I's in the parentheses, and there's my name. Iron 3 oxide. Any questions? Yes?
Honestly speaking, I didn't understand any of that.
That's awesome. You didn't understand any of it. Yeah.
I get the point.
That is honest.
I get get like.
More people should say that. They really should, because I stand up here and I explain stuff, and I'm like, any questions? And people go like, and I'm like, okay, well, either they're so lost they can't even formulate a question, which is probably true, or it's just very, very clear to everybody. But if nobody says anything, what am I supposed to do?
Like, I was with you up until the point where you started separating oxygen and iron. I understand the naming.
So you understood this part and leaving a space for a Roman numeral. This needs a Roman numeral because it's not in that other group, right? Everything else that's not group 1A, 2A, 3A, zinc or silver, we need a Roman numeral. But it was this part that was confusing. Is that what you're telling me?
Mm-hmm. And then you named oxygen oxide because of the subscript, right?
It doesn't have anything to do with the 3 here. Oxygen is, I think of oxygen as being feminine. So oxygen's the woman, and she's getting married to iron, and so she changes the ending of her name.
Well, how do you choose between oxide or oxate? What are the other ones?
Okay, so the other ones that end in 8 are all polyatomic.
Oh, so it's always going to be iron.
It's always "-ide". Yeah. So if you have a single nonmetal here, you change the element's name ending to "-ide". Every single time. Nitrogen becomes nitride. The 8 and the "-ite" thing is the polyatomic ions, and you memorize those. We're going to talk more about them, but you just have to memorize them. So the O here being, because let's think about it this way. So you look at this formula, Fe2O3, and you look at the first element, that's a metal. Okay, so this is an ionic compound. I'm going to cover up the metal. Everything else is the anion. But there's only O. There's 3 of them. This is like polygamy, I guess, but we're not going to go there. There's 3 of them, but it's just a single element. And so I take her name, oxygen, and I change the ending to "-ide". So now let's talk again about how I did this. So what I'm going to do is I'm going to erase that. And we'll start that over. We'll maybe use blue. Blue's kind of a calming color. Right? So I need to identify the 2 different ions. Right? So I've got iron, I've got Fe, and the other one is oxygen. This 3 is not part of oxygen's formula. It tells me I have 3 oxygen ions. Okay, so when I write this, I'm not going to write O3. This is 3 of those oxygens. So I find oxygen on the periodic table, and I ask myself, what charge does an oxygen ion have? -2. Okay, so that's -2. What charge does the iron have? I don't know. It's not in groups 1A, 2A, 3A, zinc, or silver. So I don't know. I have to figure it out. And I'm going to figure it out based on the fact that I've got 2 irons and 3 oxygens. I know the charge on the oxide. I think it's simplest, especially when you're getting started, to just draw them. So there's 1 oxygen, here's another oxygen, there's a 3rd oxygen. Because it's O3. I got 3 of those oxygen ions. I know the charge from the periodic table. Fe2. That tells me I have 2 Fe's. So I'm going to write Fe twice. You with me? Okay. What I know is that these have positive charges. I know what these negative charges are, and I know that all of the positive charges plus all of the negative charges have to add up to 0. So they can cancel out. So this can be neutral. So I'm going to figure out, well, what's the total negative charge? -2, -2, -2 gives me -6. And so that tells me that the total positive charge has to be the same number, just the different sign.
So you kind of did it backwards?
Yeah, this is kind of backwards of what we were doing before,
Okay.
where we started with the formulas for the ions and we made the compound formula. Now we're taking it apart to figure out what a charge is.
So now you're just separating it, because I
Yeah.
think you can either go 2+ or 2, 3, right?
Yeah, it can be +2 or +3, and we have to figure out what it is. So total -6, that means there must be a +6, And I'm going to take this, I'm going to divide it between two things, and that's how I know that this is positive 3 and not positive 2. Okay?
Miss Kate,
Yes.
Is there like a fluke for this one? Because like the iron is 2 and the oxygen is 3, so 3 times 2 is 6, and then divide it. Does that work?
It does kind of work. It's not really a coincidence that 2 times 3 is 6 and there's 3 of one and 2 of the other. It has to do with least common multiples. And I'll show you this, but I'll tell you to be very, very careful. Sometimes you can uncrisscross and get the right answer. Sometimes. I really don't recommend it though. I mean, the crisscross method, probably 90-95%. I think that's pretty good. Uncrisscross is probably more like 50%. So I don't recommend that. But if you were to uncrisscross, the 3 becomes the charge on the iron and the 2 becomes the charge on the oxide. Sometimes it works, sometimes it doesn't. So be careful with that. Any other questions? So let's name this compound PbO. We could call him Peter. No, we gotta give him a real name. So look at the first element. Is it a metal? Yeah. Is it in groups 1A, 2A, 3A, zinc or silver? No. Okay. So Pb is lead. So we're going to write lead's name. It's not in the special category, so it needs a Roman numeral. We're just going to save a space for it. Cover up Pb and look at what's left. It's the O. Oxygen becomes oxide. Oxide. Now we have to figure out charges. So I'm going to write, I have two ions here. I've got Pb and I've got O. I'm trying to figure out what the charge on the lead is. I can, well, it could be 4 plus, but let's, we have to figure it out, yeah. We could guess. But I know what the charge on oxide is. It's -2. So then I'm going to look at the formula and make sure I've got the correct number of each of these drawn in my little picture here. It's just 1 and 1. So I have a total of -2 charge. That means the total of the positive charge must be +2. And all of that has to be on this one ion. So that's a +2. So it's going to be lead 2 chloride. Oxide. Lead 2 oxide. Yeah. 1A, 2A, 3A, zinc or silver.
Would it always require you to see if you need Roman numerals?
If the metal is not in groups 1A, 2A, 3A, zinc or silver, it always needs a Roman numeral. It always does. And so you ask yourself, is this in groups 1A, 2A, 3A, zinc or silver? No. Okay, I'm going to put a space for the Roman numeral, finish the name, and then go back and figure out what the charge is. Okay? Let's do this one. Cu2S. Cu is a copper, it's a metal. Is it in groups 1A, 2A, 3A, zinc or silver? No. So I'm going to write copper, and I'm going to put a Roman numeral. This is a little bit like, you've got Joe Sr. and Joe Jr. in the house, right? And you call them up and you're not sure which one you got on the telephone, right? So copper, because it's not in groups 1A, 2A, 3A, zinc or silver, I know that there's more than one variation and I don't know which one I have. So I need a Roman numeral. I'm going to worry about it later. S is sulfur, that becomes sulfide. So I've got copper blank sulfide. Now I'm going to make a little picture over here. When you're first starting out, you really need to just write these out. Once it clicks in your brain, you may be able to just look at it and say, oh, it's this. That's not happening yet. So I've got Cu and I've got S. I don't know what the charge on the copper is. That's what I'm trying to figure out. What's the charge on a sulfide ion? 2-, because of its position in the periodic table. Now let's make sure I have the right number of each of these. There's 1 sulfur, but there's 2 coppers. So I'm going to draw another copper here.
So the charge would be +4.
Yes, the charge will be +1. But let's slow it down for the people who didn't get it, right? So the total negative charge is -2. This is a neutral compound, so the total positive charge has to be +2. These guys have to add up to 0. So here I've got +2, and that's going to be shared between these two ions. They're each +1. Okay? So that's copper 1, and I'm going to put Cu with a capital I, Roman numeral 1. This is not this number, the subscript. It's not the subscript. The subscript comes about because of this number, but they are not the same. It'll be different depending on what the charge on the anion is. Any questions? So let's talk more about those polyatomic ions. The oxyanions is what we call them, because they're anions and they have oxygen in them. So they're oxyanions. There was that whole big list, and most of those in the polyatomic ions table are oxyanions. It's a little daunting to think about memorizing all of them. You don't actually have to memorize all of them. You memorize the ones whose names end in -ate. So things like nitrate and sulfate. So nitrate is NO3 minus because I memorized it.
So only that one you can memorize, right?
Well, you only have to memorize the nitrate because there's a pattern. Nitrite is the light version. So if I memorize what nitrate is, nitrite is the light version. Like they said, Bud Light has 1/3 fewer calories than regular Budweiser, right? Nitrite has 1/3 fewer oxygens than regular nitrate. Nitrite means I just take away one of the oxygens. The numbers of nitrogen stay the same, the charge stays the same, it's 1 fewer oxygens. This is sulfate, SO4 2-. 8 does not mean that it's a -2 charge or a -1 charge. 8 does not mean that there's 4 oxygens, sometimes there's 3. There doesn't really seem to be a great pattern in there, so just memorize it. This is sulfate. You memorize it. Sulfite, everything's the same except the number of oxygens is 1 less. Okay? What if we had iodate? Iodate is IO3 minus, just because. Iodite is the light version, IO2 minus.
So the word nitrate is always associated with 3.
No,
No?
it's not associated with 3. It's the one you memorize. Sometimes it's 3, sometimes it's 4 oxygens. Phosphate has 4 oxygens, sulfate has 4 oxygens. Nitrate and chlorate and iodate have 3. So you just have to memorize. You know, I wish it could be better. It could be way worse. Really it could. So you just memorize that. Flashcards, scraps of paper, put iodate on one side and the formula on the other. Just memorize it. But the ite is 1 less oxygen. We have to be really careful when we spell these things, okay? Because iodate and iodite are different substances. Nitrate and nitrite are different. There are nitrites in preserved lunch meats. Those aren't good for you. Nitrates, not harmful. Okay? 1 letter different. Like, oh, why do we have to be so concerned about details? Well, think about email addresses or telephone numbers. You get 1 digit wrong in the phone number. You dialed 558 instead of 559 for the area code. Are you going to get the person? No. If you get 1 letter wrong in the email address, it's not going to go to the person you intended it to. There are things in life where every little detail is important. So if we can get telephone numbers right, we can get these formulas correct also. So some of these have more than 2 in their series. So chlorine is one of these. Here's chlorate. Chlorate is ClO3 minus. Why? Because you memorize it, it just is. They decided to call it that. Here's chlorite. It's the light version. It's got one less. But there's also this one that is like an extra light version. So this has got a prefix in front, hypo. Hypo is a prefix that means below. Where does a hypodermic needle go? Below your dermis, below your skin. Hypo means below. So this is chlorite, but even one less. So it's hypochlorite, one less oxygen. Here we've got chlorate, and now we've got one more oxygen. If someone has too much energy, we say they're hyperactive, right? Per is the end of hyper, it means more. Perchlorate means you've got one extra oxygen. The number of chlorine stays the same, the number of the charge stays the same. Look, here's bromine, exactly the same pattern. Iodine, exactly the same pattern. Iodine, bromine, and chlorine are in the same family. They're nonmetals. I think of them as feminine. They're sisters, right? They like the same things. They do the same things. So actually, the only one in here you need to memorize, oops, pointing to the wrong one. You need to memorize chlorate. Memorize that one. Learn this pattern, which is, I think, not too hard, right? So the pattern is if you put one less oxygen, that's the light version, that's chlorite, and then put the prefix hypo, meaning even more less, right, even less, hypochlorite. If you want more, you put perchlorate. Bromate, we just swap the sisters, swap bromine for chlorine. This is the same overall pattern, it's just bromine O3 minus instead of chlorine. And for iodine, it's IO3 minus instead of chlorine. Yes?
Can you talk about what it means by more than 2 ions in the series?
Okay, so this chlorine and oxygen make a series of 4 ions. And we name them following this pattern. Over here, we've got nitrate and nitrite. There's actually no pernitrate or hyponitrate. Do you need to know that they don't exist? No, because I just won't ask you about them. There's no persulfate or hyposulfite. There's only the 2. Most of them only have 2, but some of them, like these guys, there's 4. You don't need to know which ones actually exist and which ones don't. So you can follow this pattern on any of them and it'll be fine. I'm not going to give you questions of things that don't exist. Does that help? Kind
So
of.
the series is like which?
This one.
Together, but in different proportions?
Yeah, these are similar. Okay, they're a series because they all have one chlorine and they all have -1 charge and they have oxygens, but what's different is the number of oxygens. So that's the series. Now, mastering chemistry, if it asks you to name ClO2 minus, it's going to want you to say chlorite ion. It's going to want you to type the word ion in there. I'm just giving you a heads up on that, as picky about it. Personally, I don't care, but mastering chemistry seems to care a great deal. So just humor it. Type the word ion. A lot of these polyatomic ions are in everyday substances that we use. So sodium hypochlorite. Hypochlorite is that ClO minus ion. That's the active ingredient in household bleach. It destroys color-causing molecules and it kills bacteria. Sodium bicarbonate, that's the old name, sodium hydrogen carbonate, that's what baking soda is. It's basically pure sodium hydrogen carbonate, polyatomic ion. Calcium carbonate is used as an antacid. Sodium nitrite is a preservative for packaged meats. Inhibits the growth of bacteria, especially those that cause botulism. It's not good for you, the nitrite isn't good for you, but botulism is a lot worse, right? If you used sodium nitrate, that would not help preserve your food. It's got to be the nitrite. Okay, so let's name some compounds with polyatomic ions. So here we've got MnNO2. So look at the first element. Is it a metal? Yeah. Okay, so what's its name? Magnesium. Nope. Manganese. My favorite one that students come up with is manganesium. You're like, I'm not sure which one, so I'm going to put both of them together. Manganese. Is this in groups 1A, 2A, 3A, zinc or silver? No. So what does it need? Needs parentheses for a Roman numeral to be determined later. So that's the first ion. Cover it up. Everything else is one ion. Don't tell me it's nitrogen dioxide or something crazy like that. Creativity is not valued in naming compounds. So we've got the manganese. All of this is one name. So that's the NO2 minus ion. If you don't know what it is, take a guess and then look it up. What would be a good guess? Nitrite or nitrate, right? It's nitrogen with oxygen. It's going to be one or the other. So you got a 50% chance of guessing right. If you make a guess in your mind first and then look it up, you'll memorize them faster than if you always just look them up. So this is nitrite. So there we go, nitrite. I need to figure out what the charge on the manganese ion is. I need the charge on the nitrite ion to do that. I've got 2 nitrites. Because I've got parentheses with a 2 on the outside. I've got 2 of those bundles, and I have 1 manganese. So my total negative charge is -2. My total positive charge has to be the opposite of that, +2. What's the charge on the manganese ion? Positive 1?
But don't you need 2 of?
But I only have 1 of them.
Oh, you're good.
Okay, just checking. I do screw up sometimes. Usually at least once a day. So then this is manganese, Roman numeral 2, nitrate. This is a bit overwhelming at first, but there really is a beautiful pattern here. And once you get the hang of it, it's kind of like riding a bicycle. Yeah.
Are the prefixes like mono and di only for the molecular compounds and never?
Yes. The prefixes mono, di, tri, etc. are for molecular compounds. There is an ion called dichromate, which is an unfortunate name, but generally those prefixes are not used for ions. Let's look at this one. I think we should call that one cocoa. Okay, so I have 3 elements here. I have C, lowercase o, I have C, and I have O. So I'm going to look at the first one. Is CO a metal? Yeah, this is an ionic compound. So CO is cobalt. Is it in groups 1A, 2A, 3A, zinc or silver? No. So I need a Roman numeral, put the parentheses in there. Now, I don't want to separate the rest of this. I've got 2 things, okay? This is like marriages between one person and another person. It's just 2 people. And in chemistry, it's based on charges, so we can't have anything else happening. But there it is. I mean, it's just got to be positive ion and a negative ion, okay? Just 2. So positive ion was cobalt. Everything else is the negative ion. You can't make that into 2 different things. It's a unit, okay? So the other thing is CO3, which is carbonate. Oops, not carbonite. That's an online backup system for your computer. Carbonate. So then we're going to go over here and make our little scribbles. So we've got CO, and we've got CO3. And carbonate has a charge 2-. Why? Because it just does. How do we know it does? We memorize it. And until then, we look it up. So I have 1 cobalt and 1 carbonate. If this one's -2, what does that one have to be? +2. So this is +2. So this is cobalt 2 carbonate. Is it beginning to make sense? A little bit?